Okay, so dilations, they are non-rigid, and you end up with two figures. Somebody mentioned that the dimensions are all different. That's halfway true, right? Any linear side lengths would be different, right? But what would be the same if we dilate a figure?
Structure.
Okay, what part of the figure causes the shape? The angles, right? So the angles stay the same, okay? And of course, we talked about it before. We have a scale factor of our dilation, you know, like how many times bigger it gets or how many times smaller it gets, right? So scale factor, if the scale factor is greater than 1, we have a dilation that we call an enlargement, okay? So this would be for K greater than 1. Remember, K is what we use for scale factor most often. If the scale factor is between 0 and 1, what does that mean? What kind of numbers are between 0 and 1?
0.5,
1.5, 1/2, 1/3, right? That kind of thing?
6, 9.
Sure, any of those. If it's between 0 and 1, it's not an enlargement. The dilation would be a what? Reduction, okay? Which makes sense, right? Because 1/2 is between 0 and 1. If you dilate by 1/2, it's half the size, right? So it's a reduction, okay? Kind of. This right here. What does that say? This is very... Okay, so there's always a lot of confusion when kids encounter this the first few times. The way I like to read this, like in regular English words, and I think this will make more sense, when you see something like that, you could just say in your head, K is between 0 and 1, right? If 0 is less than K, which is less than 1, we want to just say K between 0 and 1, okay? And I'll put it up. So scale factor, you might see like this, 1:2. I really don't like it that way. It's not as mathematically useful, right? So you might say, you know, I might say, write it like this, but the scale K of 3, it's a 3-to-1 difference, right? Okay. And that's just read 3, 2, 1. For like that, because then we can do math stuff on it when it's in this form, okay? And by the way, please, no more, if any of you do your fractions with the diagonal line, that is incorrect. Stop doing that, okay? It's not, that's like not, that's for like the general population out there who doesn't do math, right? That's just like the final result to display something, I guess. It's, yeah.
I learned in Algebra 1 to do that.
To do with the diagonal?
Yeah.
Okay. It is technically incorrect when you have it in the midst of some mathematical operation you're doing, and at some point I'll explain why, but I do want you to stop. If anyone's doing that, horizontal fraction lines, okay?
Would we get points off of the difference?
No.
Depends on the situation.
Generally.
If it was one of yours.
If it makes something unclear, and I will at some point demonstrate how it would, okay, it could.
Would we get points on like one?
Yeah, so not, if it makes something unclear in the midst of what you're doing, and at some point I'll show you how it will, okay, it possibly could. So just, anyway, I mean, that's, if you're using a diagonal fraction line, you're not really presenting yourself as a math student, okay, you're just kind of a schmuck barreling through a class or whatever, right? What's that?
If you put like a little explanation of that is the effect.
3 to 1?
That's too much.
Why would you do that?
If you have enough time in your day, I mean, you know. Okay, let's see, where are we at here? So, in these scale factors, we usually put them in lowest terms, okay? So if we take a look at these two figures here, right? So one of them got dilated, right? What happened? Which one got dilated?
A prime, B prime, C prime, D prime.
Well, that is the result of the dilation. Which one got dilated? Yeah, because ABC and reduction or enlargement.
Imagine if
Bigger.
It's an enlargement, right?
bigger.
Okay, so we can figure out the scale factor by looking at the side lengths, right? So when we apply a scale factor to a dilation, that multiple gets applied to every linear measurement, every side length, okay? All right, and so the way to find the scale factor, well, let's just take 4, this side 4. What did it become? 12, right? So 12 over 4, 12 to 4. Do you agree that this is a 12 to 4 dilation? Okay, what is 12 to 4 in lowest terms? 3 to 1, right? And we can also check it with any other side. 16.5 over 5.5 is also, it reduces to 3 to 1, right? Etc. So these are all lowest terms. And for the most part, we'll always want to put it in lowest terms. There is a section later on where we will leave our scale factors and slopes unreduced for another particular purpose, but we'll get to that later. Okay?
I can't do those things.
Stakes practice. Okay. So let's look at some properties of a dilation, okay? So a dilation has a center, right? It has two things. Like if you're going to explain something as a dilation, like all the other transformations, you got to be specific, right? Like a rotation has two bits of information, right? The center and the degrees of rotation, well, three actually, because which way, right? Positive or negative, okay? Like that. So dilations also have some information that need to be included, and that is, you have to talk about what is the center of dilation. So you can dilate about a center point that's either outside the figure, or it could be on the figure, or it could be within it, right? And it makes quite a bit of difference. And a scale factor, right? The multiple. I've talked about that. So if we're going to dilate, say, just a line, right? Not two-dimensional thing, just a one-dimensional line, okay? If we have a positive scale factor, right, then that segment gets longer, okay? Make sense? To find the scale factor, like we did on the page before, what did I do? I took the length of the new image and divided it by what?
The
Corresponding pre-image, right? So scale factor, really, if you look at this here, OP prime would be the new measurement, and wouldn't OP be the old? Right? Okay? So we could say, if you ever want to find K, it's this, and keep this in your memory banks. So it's just image length, image over pre-image. Right? Or if that's hard to remember, probably the easiest way for me to remember it is I just do, or it's new over old. That might be easier to remember, right? So whatever new length divided by the old length, the corresponding, right? Okay? So here's what happens if this is K, right? This OP prime divided by OP. So that's K is greater than 1. So it's an enlargement, right? So from the distance from O to P was this far, and now it's even farther. So it was an enlargement, okay? Looks like it's not even a full doubling, right? Maybe it's an enlargement of 1.5 or something. It's hard to tell, okay? Now take a look at this here. This is our K. I'll rewrite it like this. What's a good way to read that, what I just wrote?
K is in between 0.
K is between 0 and 1, right? Simplifies it. So if the distance from O to the pre-image P was here, now it gets closer because it's a reduction, okay? So let's say the scale factor was a half, all the distances get cut in half. Simple enough? From the center point. All right, and so we have some notation. So I'll just write this, I'm going to make note of this. So this could just be read K is between 0 and 1. You'll see something like that. All right, so here's our notation, shorthand notation, right? The mapping notation, coordinate notation, whatever you want to call it. Of course, it's a dilation, so it makes sense to use a D, right? And now we have a little subscript here, right? 0 or O, comma K, all right? So in the subscript, that first thing is the center of dilation. Okay? And if you're in the coordinate plane, it might just be like an XY pair of coordinates, right? And of course, K, is the what?
Scale factor.
Scale factor, or the multiple of enlargement or reduction. Okay? And remember, that K, that scale factor, applies to every linear measurement. You know what linear is, right?
Which line?
Measured in a straight line, okay? Not like square, so you know what square measurements are, right? What is that?
don't want to say units, I don't think that's
Like if you had square inches, what are you talking about?
like
Perfect.
Area,
Perfect.
right? Area is always in square units. So we have to do something different with K if we go to area, and then something different again if we go to volume. We'll talk about that in a little bit. But here's some properties of dilations. So obviously, they're not isometric, except for one case we talked about a while ago. But
The S. No.
hang on, we'll get there in a second. So first thing, we already talked about it a minute ago, was after dilation, all the angle measures stay the same. They don't change, okay? Otherwise, the shape would change itself, okay? Parallelism. Things are parallel after we dilate. So if things were parallel in the figure to begin with, they're still parallel, right? And also, if you dilate, all the corresponding side lengths of the figure between the pre-image and image are parallel, okay? So I might note that also, corresponding sides are parallel afterwards. All right? Collinearity. What does collinear mean? Anyone know?
No.
Well, you know what linear means, right? What's linear?
Went down the line you made up.
Linear refers to a line. So collinear, if 2 points were collinear, what could you say about it? They lie on the same line, right? Right? So if they lie on the same line, okay, and you dilate, then they stay on that same line. Kind of like this one up here, right? We dilate at point P. The center here was on the line that we're dilating, so it stayed. Okay? And we'll look at some other cases. Distances are not preserved, and they put that big roll print there with exclamation points as if there's no exception to that rule, but I bet you some of you remember what the exception might be. Like, when would a dilation result in something exactly the same size?
one.
Unless, yeah, your multiple K is 1. So a dilation in one particular case could be isometric, right? I mean, it seems almost pointless to think of it. Well, why call it a dilation, right? Well, so you won't do anything to it, but just keep the concept in your head, okay? All right, what do we got down here? Okay, proportional. Do you guys know what proportional is? Okay, here. Okay, we have to make a distinction. Oftentimes when I ask what is a proportion, kids will tell me a ratio. You're almost there. They're not the same thing, okay? A proportion is made up of 2 equal ratios, okay? Do you remember those things where you cross multiply? That was a ratio equals ratio, and you cross multiply. That was a proportion, okay? So a ratio is just one number compared to another number, top and bottom, right? Okay? The proportion is 2 or more equal ratios. Keep that in mind, okay? The orientation doesn't change, okay? So here's an example of a dilation of a triangle, right? See where the center point is? It was not on the figure when it started, right? And so what you can do when you do dilations is starting at that center of dilation, take your straight edge and draw a straight line through each of the points of the original triangle, the pre-image, right? And then if the scale factor is 2, whatever that distance is, you double it. Double that distance, okay? And that gives you your new image, your dilated triangle, okay? What if the center of dilation was on the figure? Let's say they dilated this about point P instead of over here. Where would point P move to? But it's on the center of dilation. It would stay right there. All the other points would get bigger, right? It would stay right where P is. That makes sense? And notice here, after this dilation, do you see side PC here and P prime C prime? What can you tell me about them?
They're farther apart.
That's true. What can you tell me about them? They're parallel, right, after the dilation, as are all the other pairs of corresponding sides there, okay? All right, so let's talk about scale factor for a second and what it applies to. So K scale factor applies to corresponding side lengths, okay? All right, any linear measurement in your figure, you can apply K to it, or use them to figure out what K was, right? What else is a linear measurement in a figure? What's the distance around a triangle called?
Perimeter.
Perimeter, right? So we could apply, like if you said we're going to dilate this triangle by a scale factor of 3, well, each side will get 3 times longer, but what about the perimeter between the two? Will that also be 3 times longer?
Yeah.
Yeah, okay, because it's linear, right? It's a linear measurement, not squared or anything, okay? So it would apply to perimeters. Now, if you're in the coordinate plane, right, and if one point of the triangle has a slope, you know, rise and run to get to another point of the triangle, could we apply the scale factor to the rise and run as well, the slope? Right? So if we double it, so if the rise is like up 2 and right 3, and we double that, you just go up 2 and right 3 again, don't you? Wouldn't that double the slope? Okay, and that'll be handy when we're in the coordinate plane doing these things too. So it also applies to unreduced slopes. I say unreduced, right, because when I'm counting in the coordinate plane, if it goes up 3 and over 6 to get there, then you're going to go, if it's scale factor of 2, you're going to double that unreduced slope.
Would it,
I'm not done.
would it also apply to the area too?
We're going to get to that. I'm going to let you guys think about that, actually. Unreduced slopes, right? And the lowest terms would stay the same. You'll see what I mean. What's another linear distance? How about the distance from the center of dilation to any point in the figure? That you would apply K directly to those too, okay? So distances from center to corresponding points. From center, distances from center to corresponding points. Okay? Now let's think about area. Think about a rectangle. How do you find the area of a rectangle?
Multiply the
Length times width, or base times height, right? Whatever it is, okay? Now let's say we dilate the rectangle by 2. So what do we do to the length and the width? Multiply them by
2.
2. Okay, give me a picture in your head.
Would you divide it by 2?
No, scale factor of 2. So I'm going to multiply each dimension of the rectangle by 2. So it'll be twice as wide, twice as long. Agreed? Now what about the new area? If someone asks you, well, if you knew that, let's say the area of the original rectangle was, I don't know, 5 square units, right? What would be if you dilate with 2, what do you think the new area would be in the new rectangle that's twice the size?
and 4.
Doubled?
Yep.
But wait a minute. We have a rectangle. We multiply, okay, so L times W. I get, how do you, whatever. How about base times height, right? Now let's double the base, B. So now we have 2B and 2H.
What's usually not nothing between there?
So there's a 2 here to get the new area and a 2 over here to get the new area. What happens to that 2 when you get the new area? That scale factor.
Multiply with it? Scale factor?
Rectangle, right? Let's say that this is height and that's base, right?
Oh, dilution happens.
Yeah, so let's say now it's a K equals 2. Sure, you might as well. And now I have, like, maybe like this, right? Roughly. So now this is 2 base and 2 heights, right? And now, so if I find the area here, it's B times H, right?
Mhm.
Okay? Is this now, so you're telling me that the area now is gonna be twice V times H?
No, it's way more than twice.
Okay, how much?
4 times.
4 times. What did you do to the 2?
You know,
Well,
Squared it,
squared it.
right? You see how you cannot apply scale factor K directly to get new areas?
Mhm.
You kind of see why you have to square it now, right? It's easy to remember, what kind of units is area always in? Square units, right?
Why did you put an out?
An L,
Out.
that's an 8.
that's an H. That's a sloppy H. Better? Okay? So to get area, right, between the original, the pre-image and the image, you have to use K squared. So K squared applies to areas. Are you grasping that? Because that's a pretty common Regis question. We'll try to trip you up on, right? We'll give you a triangle or something dilated, you know, the scale factor of 3. How many times bigger is the new area? Well, what would it be? 6 times? What? Huh? 9 times bigger. More area, right? Because you got to square the scale factor of 3. That makes sense? Okay, and you won't see much of this, though. But let me ask you this, just to pile on this one. What about volume? What would we have to do to K? Cubic, right? Because isn't volume length times width times height? Cubic units, right? Cubic inches, cubic centimeters, yeah? I say so. Yeah, I looked at the keyboard too. Right? So if you ever have to apply it to volume, you'd have to use K cubed. Okay? So K by itself, you can only apply to just linear measurements in the situation. Okay? If you move on to talk about area, what do you have to do to the K? Square it. Okay? That's easy enough, right? Okay. So let's go, we're combining 3.2 now. So it rolls right in. Okay? So they want us to determine whether we have enlargements or reductions, right? We got to think about whether K is greater than 1 or what?
Reduction.
Between 0 and 1, right? So less than 1, but a little more specific, right? Between 0 and 1, okay? So if we have a scale factor of 2 to 5, and again, I prefer it like this, 2 to 5, what would that be?
Enlargement.
Because you would agree with this, right? Enlargement. You would agree it's a reduction, right? So we're going to be 2/5 the size. The next one there, well, how do we know that's a reduction? It looks like it gets bigger.
Just the primes are
Oh. So look where the center is, right? Where you can do this kind of thing. Use a straight edge if you ever do it, right? But it got smaller along this path, didn't it? Right? So that's a reduction. Look at the notation there. Dilation centered at 0. The scale factor of 5 of point A. 5 is greater than 1, isn't it? So easy enough, that's an enlargement, okay? So why don't you guys take a second, go down here. You're going to look at these and just determine, just circle, reduction or enlargement, okay?
I don't understand what you're talking about.
Ah,
Just
Thank
read
you.
that part so Abby can get it.
Abby who?
which part? Well, we'll get it on the next one.
Who cares? Who?
So let's
Should
take
have came to school.
the next one.
I don't care.
What's the center of dilation in this one?
Or-
R, okay? What point is getting dilated?
It's less than
Where's the F is here? And what's the scale factor?
1/2.
So that means it's distanced from the center. What's going to happen to it? It's going to get cut in half. So what was the distance? 1, 2, 3, 4, 5, 6.
So that's 3.
Now the distance is 3, so it gets closer, right? So now you see F becomes W?
Yeah.
What is the D?
Dilation.
Dilation.
Okay.
Okay.
Nobody.
Let me erase this.
My mouth smells like vanilla.
Mine sounds like vanilla.
So, so next one.
They all smell like
Quiet. What's our center of dilation? P. Right here. What? Oh, okay. Here they're going backwards. What was the result of the dilation? So we started at P and we ended up at R. Okay?
But that's
What did we do to the distance to get there?
-4.
So whatever the original distance was, we multiplied that original distance by what? 4. Well, what's the new distance?
R
The new distance is, okay, we're going left. Think of the number line.
2
Negative.
-3.
-4, isn't it? The,
What the midpoint is.
so from here to here was 1, 2, 3, 4.
Midpoint is.
That's the result of multiplying the original distance by -4. So what was the original distance? Okay.
I'm sorry.
1.
One from W.
I thought we were looking for letters.
Yeah.
What now?
I'm a little confused.
Yeah, the first two I was good with, but now this one.
So we dilated some point. And where did the final result end up? We're going backwards now.
Ended up.
We ended up at R. And this tells us whatever the original distance was from P, we multiplied that by 4.
So
Oh, it would be
You probably should be thinking of it as negative.
it's gonna be 1.
Okay? So what was the original distance if when we multiply it by 4, it became 4?
But I thought instead of 1, if
1.
you use the center point, then you're supposed to go forward.
But P is not the center point.
Right. So technically, I'm thinking that should say -4 here. But anyway, let's forget the negatives.
I'm sorry.
Absolute value is now 4. What was it? 1. So the point originally was W.
Sure. I'm confused though, because I'm not here with regression. So
I know. I think I spotted an inconsistency in here. I think, quiet. I think what they probably should have had here was -4.
Yeah.
That's gonna go
Okay.
with R. So
I think and I'll probably make that change for next
How do we
group.
do B on the bottom? It's a negative.
Okay.
why are you going
So- Right now, yes. Yeah.
Jordan, did you fill this out?
Right now, you guys do these A, B, and C down here, right?
Are we supposed to use that same one?
You're using the same line, yep. So know what the center is, know what the scale factor is, and just multiply the original distances by that scale factor. And you'll land on the correct point. The first one there, A. How many got T? It is T. Let's take a look.
Yeah.
If you didn't get this, just don't talk and listen to me. What's this? What's the center of dilation?
H.
So let's start here at H, okay? And what point is getting dilated?
Okay.
K. What's the current distance? Right? And what are we doing to that distance to get the new one?
I'm going back there.
Multiplying by 3. Times is not a verb.
That's okay.
That's the center, yes.
But why would it go right?
So you do like 6.
There seems to be a bit of inconsistency here. Let's just gloss over that for now so we can get the spatial mechanics underway, okay? So
I would have done. Okay, so how are we gonna go more right if we've been going right?
let's forget about the left negative for this one. All right. Granted, this is inconsistent, all right, but we can still get the spatial part out of this, right?
So how do we do that?
So probably should be -3, okay? So the original distance was 2. Now it's going to be what?
3.
6. You multiply the original distance by 3. So now it's instead of 2, it's 1, 2, 3, 4, 5, 6.
Just T.
T.
I got that.
So
Yeah.
and now they're going to try and be consistent and throw a negative in there, but I don't know.
-2.
I guess I had
T.
one of the things I need to go back in and
How are
rectify.
we gonna go? What?
I don't.
It's backwards, bro. Because if you can't go off the line, wrong.
Wait.
Okay,
so negative-
Okay, all right, I got it. Maybe not so inconsistent.
Maybe we're backwards.
Okay, this is what they're doing. Okay, whatever direction they are going originally, they're counting that as positive. To help.
Oh, so that.
And
going
then-
that way would
And
be-
then to reverse that direction the other way, then they gotta make it negative. Okay? I think they might be consistent here, but again, granted, it is confusing. Yes.
So it would, you would start at T, and then the distance between them is 2, and since it's -2, it would be T.
Okay, so
Is it K?
It needs T.
the center of dilation,
Just K, I got it. And I understand that.
it is K.
I think you're right, yeah.
Oh, so if
Right.
it's negative, we go backwards.
So negative B, okay, that's right, that's what they're doing. Not necessarily left and right, but whatever direction, the original direction, the negative will make it go the opposite way, if that makes, right? So, if we start with a center of T, quiet, quiet. So T is our center, we're dilating point M, and what's the original distance? 2 in that direction, right?
Yeah.
Okay. But now we're going to negative scale factor. So now, we're going to multiply because times is not a verb.
But if you were to say
I'm a
times,
grammar Nazi.
if you were to say times on a
I'm a man of many talents, and that's one of them.
Makes sense.
We don't plus things, we don't minus things, we don't times things because those are not verbs. Okay? Well, by the time you get done with me, it'll fade. Okay, let's get back to this.
I'm jerky on the scenes.
We're going 2 in this direction. We're going to double that distance, so we'll make it how far? Instead of 2, 4.
What? How?
What's 2 times 2?
Backward.
But now it's going to be negative, so in the 4 in the other direction, right?
Where did you get in the world?
2 times 2. Guys,
2.
shut up.
It's 4. I can barely walk.
Oh.
The original distance is 2 in that direction. We're going to double that and go the other direction now. So now it's 4 the other way. We end up at K. Are you feeling it a little better now, guys? Now that we cleared up what we thought was an inconsistency, but I guess not really. How about this last one? Be careful, you're going backwards. Everybody get C?
Yeah, it's D.
She says D. Anybody else think it's D?
Where's the A?
I'm trying to put it really wrong.
You worked that out in the toilet?
1/8. I think it's 8. 1/8.
Okay, so here, listen. What's the center for this one? F. And what was the result? So we ended up at K. That was the result of multiplying some original distance by an 8 or dividing by 8, right? So
To get that, you just multiply K.
something divided by 8 equals what?
You get waves.
1. What divided by 8 equals 1?
I could probably do one for
Huh? 8. So it was 8 away from F. 1, 2, 3, 4, 5, 6, 7, 8.
I was right.
You have to half it, and then half it, and then
Or just divide by 8. Multiplying by 1/8 is the same as dividing by
The
8.
backwards ones, like where you can start off with the answer, those are harder.
Well, that's like, you're supposed to think in this class. Okay, let's move on. I don't know if anything's useful here. Okay. All right, so look. So, this is not useful. Let's just move on to the next page. Don't worry, you'll get there. Okay, take a look at it. So we have got a line segment, right? It's dilated, center O, and what's our scale factor? Okay, so K is 3. They have some measurements in here, right? Linear measurements. So what happens to all the linear measurements? If the scale factor is 3, they get multiplied by 3. Okay, you know, and they put them in here, right? So B's distance from the center is 7. A's distance from the center is 6, linear measurements, and the length of AB is 8. Okay, so let's answer some of these questions here.
Yeah.
I know, let's talk about them then.
Oh.
Okay, how about that? A prime, B prime. Now we're going to find the length of A prime. How'd they get 24?
Because they multiplied it by 3.
3 times 8. They multiplied it by 3. It's not. Did you car to school today? No, because car's not.
No, I bust.
No.
That's
Yeah, that's weird
See?
too.
See?
Okay, so let's put that in here. So that's going to be 24. Now how about OB prime? 3 times 7, right? Which makes this 21. It was 7. Okay. OA prime. 3 times 6, which is 18, right? So that makes this whole thing 18. Now A to A prime. This distance here, what's that?
If that's 21, that's
well,
7.
no, it's 6
so
times 2.
21 minus 7.
Because you're doing it's
Scale factor is 3.
So
What was O to A prime is 18. That's 6. What's that distance?
18 minus 6.
So we did 3 times 6 to get 18, and then we have to subtract what?
6.
Right?
But where would you get 2 from?
Because there's only 8.
See what I did there?
Still making calculus here.
Yeah, okay.
No, not quite.
I'm really drowning in my
So this is, that little bit is 12 there. Now B to B prime. How'd they get 14? Right, so the original dilation, 3 times 7, but they're only interested in this segment, so we subtract out that one, right?
Yep.
That gives us the 14.
It's just common sense that there's 2 parts.
The scale factor is 3.
That's all I'm saying.
Yeah.
Now,
Put your mask on.
what is the ratio?
You're an anti-master.
What is the ratio of OA to AA prime? What's the length of OA?
6.
6. And AA prime is what length? 12.
Is there a-
So let's put that in lowest terms. 2?
No.
1/2.
Who said 2?
Um,
Oh, you're not.
Okay? All right, let's see if you guys can hack through this one down here. Now that we've thought about it a little bit.
I think I can do this.
All right, I want everyone quietly taking a. Well, let's see. What'd you guys get for A prime, B prime?
2 centimeters.
Good. Tell me get 2
I
centimeters.
got 2.
Smart. My brain is so
Let's go, baby.
How about OB prime?
7.
4.
Dang.
Oh my god, my brain.
4 centimeters.
Let's go with 4.
3 for
Hang
number
on.
3.
There's a question about this.
3 centimeters.
You got it? Did she help you?
Exactly.
Okay. How about OA prime?
3.
3 centimeters. AA prime.
A prime.
How
I would
much?
say 3.
3.
So,
Wait.
How we get AA prime?
It's cut in half.
yeah.
This is that distance there.
Does that look like half of 6? Did I mess up?
You just count the dash marks.
E is 4 centimeters.
I want that.
My god, my brain is
I did. See?
It's 4.
I didn't know that. I'm walking around with my thing. I don't know.
What is the ratio?
Okay, now the ratio of OA
It's 1/2.
prime.
I got 1.
I got
Well, what are the unreduced numbers? What to what? 3 to 3, which reduces to 1 to 1, which of course is just 1. Okay? Kind of getting it now?
Sure.
All right. Let's take a look at some Regents questions.
Take a potty break.
What'd you do?
Yeah, let's take a quick potty break, and then we'll look at the Regents questions. That's great.
It's 40 minutes long.
Watch this trick. Watch this trick. You know the calculator, right? What?
It's 40 minutes long.
I know. I have to do the best I can. So, maybe I'll do like a part 2. We're going to pause it here. It doesn't work that way.